have done structural. Structural, mein you guys have covered which one so far?
Chain, position,
Mm,
functional,
mm.
ring chain, and metamerism.
And you have started on stereo.
Yes.
इसमें क्या क्या किया स्टीरियो में?
Configurational and geometrical.
You have started on both or you have already done both?
No, we started on both.
Configuration में क्या क्या किया है?
Actually, we only started geometrical, not configuration. Just like give the definition of that.
You guys have done geometrical then.
Yeah, to some extent, yeah.
Give me the examples you have talked about here. Types of examples.
Butene.
So alkenes.
Alkenes, yes.
Rings.
Pretty much, and then yeah, pretty much all alkenes. Sir.
Rings.
No rings. I mean, we had a phenyl group, but other than that,
No. Geometrical isomerism in rings is also something which is
yeah, we didn't cover that.
possible. You haven't covered that yet.
No.
Okay. Let's take some simple examples and start this out. Let's take octane. Did you already do for octane in your class or not?
Octane. No, we didn't do octane. No.
Then we'll play with octane. Get me everything possible here from octane's point of view. Get me the number of isomers for octane, please. Sit and work on it now.
Yeah, 1 second.
And after octane, we'll go for so after octane, we are going to be looking at these two cases.
Okay, sir.
See, there is no simple way of putting it across over here. Isomerism, you have to goddamn crunch the numbers. You have to sit and work it out. You have to get into a pattern and a rhythm where the idea here is
you list out each of the like in ordered manner. Like
correct.
First,
You
this
be systematic about your approach with respect
yeah.
to isomerism. If you're unsystematically doing it, you'll never get the number of answers correctly.
Sir, 18.
I have no idea about the answer for this.
Answer is 18, but
how do you know the answer is 18?
Sir, I remember this. Like
no,
I
never, ever do that in organic chemistry. Remembering will just fuck you up the ass here. Plainly because there's so much to keep track of here. Your brain will. It's like you got a huge cupboard over here where you're putting so many items. Some of them are all looking similar to each other. Never memorize an answer over here. Never ever. You can do that after you have collected like shit ton of stuff in your memory and you've got like arrogant confidence key, what to say, you have placed everything and organized the cupboard in the best manner possible, and then you're retrieving data. In the beginning, when you're retrieving data, be very careful. Avoid retrieving unnecessary data. Do not put unnecessary shit in the cupboard. Put only really critical things. At this stage, avoid memorizing unnecessary bullshit in organic. Keep your brain fresh. There is enough to memorize. Trust me, there is enough to memorize. And organic also, I think we've talked about the stages in understanding chemistry, at least at some point of time by now. We should have.
Yeah.
So memorizing is a stage. You have to go through that. If you store junk in your brain, very bad, very dangerous to basically unlearn unnecessary shit. I think you have started realizing assumptions are your biggest goddamn problem. Why is assumption a big problem for you? Why is that becoming a big problem? Explain. Why do you think that's a big problem? I don't have an exact answer, but I can see one of the answers in front of me right now. That's why I'm asking.
So like when you assume something and you start building on it, then like
So why is the assumption? I understand assumption as a whole is a problem. I agree with that part. But I'm asking, why is it a problem for you? You as an individual, why is that a problem for you? Why do you have so many assumptions in your brain? That is my question here. Others do not have this kind of unnecessary extra assumptions, right? Why do you personally have a lot of these assumptions in your brain?
instead of memorizing them, like I guess.
Why? And I'm not debating the questions about what has happened and what is memorization, what is assumption here. I'm asking, why is it specifically happening more to you? You don't see this happening to that many of your friends. After I've told you this assumption shit, you are a smart kid. You would have started looking at your other friends. You would have noticed this in your really sharp friends. But you would not have noticed this mistake in the mediocre fellows. Why? Why?
Thinking too much.
Hmm? No. You basically, it's like this. When you start a topic, now you're a very smart kid. Smartness basically means you are like a very good sponge of information. And you have like, when you start a topic, you already create a cupboard in your brain. It's already like ready-made space available in your desk. So
Yeah,
what do you do over there at that time?
fill
When,
stuff.
yes, you junk fill stuff in the beginning.
Mm.
Why? Because you see random patterns. You see too many more patterns than what normal people do. But since you have not been given the proper scope to understand what needs to go in and what should not go in, you fill it up with junk. Most smart kids do this when they're learning something for the first few times. And especially when they are the hyperactive type, they will fill up with even more junk. If you have noticed this issue, if there's a smart kid in your class who you like, who is also hyperactive in terms of engaging with teachers, they'll fill up with a lot more junk. Their assumptions will be more. At least that has been my, what to say, analysis about these assumptions, at least so far. But you have to start understanding that is not a bad thing, that is not a good thing, that is just what happens. So you have to recognize that when you are learning a topic for the first time, you are going to have this deficiency. I also have the same problem. You're going to have this deficiency. You will put blinders on where you think you know, but you don't know shit. Mainly, the reason why you think you know is because you have filled up some stuff over there, which is more than what the other
Previously.
people have filled up in their brain. That gives you false confidence. Avoid.
Yeah.
Avoid. First, do the organic chemistry is more or less going to be like physics for you. Don't take this wrong. It's going to be like that. Because organic chemistry is understanding and then playing with the understanding parts and the applications there. But to get to that understanding, you need to sit and memorize a reasonable chunk. That memorizing part is not going to be that difficult for you. I personally feel that. The next stage there, it depends on how things flow. If it starts flowing nicely in the beginning, if you're finding yourself having fun with organic in the beginning, you'll never feel it like physics. You'll find more fun. You'll find it far more fun. But if you start finding it complicated in the beginning, if you start developing resistance to the subject to an extent, things will start getting complicated like an avalanche. So, those are two ways in which organic can go. Just a general point. So let's start off. No assumptions. I do not care about the answer for octane. Let me be very clear. I do not give a shit about the answer. I want a clear-cut process to be seen where the process will lead me to the answer efficiently. You understand what I mean?
Yes.
I have a process where I am able to rule out options which are going to be replicas of what I've already done before. That's the key thing. I'm doing a set question right now. All right. I'm analyzing a large set of data where I have to now devise a way in which I am mutually exclusively identifying elements of the set.
Without repetition.
Yes. Get me a process for that.
So you can first start with 8 number of.
I have no problems. Explain. That's best. Tell me how.
Yeah. You first start with 8 number of carbons in the main chain. You only get one combination there. Then 7. Then you can go down like that.
Let's start off. So 1, 2, 3, 4, 5, 6, 7. See, the details in the process are the key thing. So start detailing. I'll write down as you are telling me. Let's go. So 7 are here. What do we do next in this 7-member chain now?
Now you can put methyl group on the second carbon from the left.
Okay.
Third carbon from the left. That'll be the same as putting 2 on the right side.
So you can put I'm basically going to be neglecting this and neglecting this.
And the middle one you can put 1.
Okay.
So you have 3 here.
Good. So
and
now
you have 1 previously.
So now 6 carbon long chain.
Yes. Yeah. And then now you can 6 carbons.
So then I have a 6 carbon long chain now. So I have 2 substituents.
2 methyl groups. Yeah. Or 1 ethyl group. First you can put ethyl group in the first and second.
So I can put it over here, or I can put it here. This location is out. This location is out. Can I put it here and here? Are you sure I can put ethyl in these 2 positions? Let's try putting ethyl.
No. You can. Then we come the main chain. No. You're right. Yeah.
So good.
So you can't put ethyl. You have to put 2 different dimethyl.
Wrong. You can't put ethyl. Where can I put?
In the middle. This third one.
So this location is ruled out. This location is in. So if you're having a 2 carbon long substituent, you should not put it in any of the 2 corner carbons from any ending. If you have a 4 carbon long substituent, where should you not put it?
Second one.
No, if you have a 4 carbon long substituent,
first one.
Where all should you not put it? In any of the corner 4 carbons.
Yeah.
All right. If you put it in any of the corner 4 carbons, the chain length will increase. So if you have a 4 carbon long substituent, you can put it in any location on the long chain, which is not in the 4 carbons from the either corner. A long chain will have 2 corners. So this side 4 corner carbons and this side 4 corner carbons, you should not put it. You can start putting it away from that, the 5th carbon onwards. And the same mirroring effect you'll have to look for. This 5th side is going to be the same as this 5th side. Fair enough?
Yes.
So if I have, say, X carbons in a long chain as a substituent, then I should put it on the X plus 1th carbon from the ending.
Yes. Yeah.
Clear?
X plus 1. Yes.
Okay. So here, if I'm going to be having ethyl substituent, I end up having this as a possibility. That means I get one compound over here. All right. Now let's go for same 6 carbon long chain now. So in this case here, I want to put 2 methyls.
Yeah.
Where can I put them?
First you can fix one.
Give me numbers.
You can put one CH3 in the first one. Sorry, second one. Oh.
Give me numbers. Where all do you want them?
On CH3, on 2 you can put one CH3. Fix it there.
2, 2.
Oh, like that. 2, 2, 2, 3.
Then
2, 4, 2, 5. And then you can fix it at 3. Then you get.
Remember now, what are you doing here? When you're doing it in this fashion, you went
repetition.
With the... Yes. Yeah, repetition. How do you remove the repetition? That's my question here.
Oh, you
make sure that in this particular case, no 2 should appear here.
Yes. Yeah.
You understand why I did this now?
Yes, sir. Yeah. 3, 4 you can put.
The way you went, you would not have gotten here. Numbers are far more efficient to keep track of than anything else. The process, the steps in the process do matter. The small steps do matter, because if you end up doing if you did what you did over there, what would happen? Keeping track will be very complicated. Making sure you're getting through all is not going to be systematically done. And keeping track of what is going to be repeated is going to be a lot more of a complicated game in your process. The sub process you started off with over here, I do not like that. That's why I switched into this.
Okay. Yeah.
So you understand why I did the switch over here? and why I did not switch in the first case. In the first case, I was happy with the process. Here, I switched because this is not exactly mutually exclusive, and
prone to errors.
Having issues when you run into a bit more. In the second and third example, you will see. You'll run into shit there. Now, here.
3, 4, 3, 5.
So 3,
4.
4.
And then 3, 5 will be the same as 2, 4.
Good. That means what's the point over here? What's the point here?
It's repeating. So if we did like that, then we would count this also and we double.
You're understanding the point over here. You should make sure that in this particular case here, 2's all are done now. Basically, that location, which is one corner carbon away from the corner, is bad.
Other side. Yeah. So if it's 2 then 5, then
that both of those locations are banned from now on. Anywhere in the middle you can put and find arrangements according to that. Okay, so what else? You have missed out on one here.
3, 6 or 1.
Wrong. How can I have 6?
1, 3. No, you can't do that. Sorry. Sorry. 3, 3.
Good. So the mistake you made was you basically ended up starting with the 3, 4.
Yeah.
That was bad.
Yeah.
So 3, 3 first, then 3, 4.
That's it.
That's it. So how many do we have totally? 6.
6.
Now let's go for the next one.
5.
Okay. What are the possible ways of putting here?
Well,
one propyl if I can. Can I put a propyl here?
Propyl you cannot put.
I cannot. Good. But I can put one ethyl then.
Ethyl
so and one ethyl and one methyl. Where should the ethyl be?
It should be in the middle.
Good. So ethyl has only one location available.
And
so ethyl is fixed. Now where can the methyl go?
2 locations, 2, 4. No, same thing. My bad. No, sorry. Only one location. No, 3 locations. 1, 2, 3.
You have to structure your brain a little bit more. 1, 2, 3,
3, 4.
3, 4, 5. Methyl na? Where can I put? Tell now.
2. 3. Yeah, that's
correct.
Yeah.
So what do I have? I have 2.
2 combinations.
For this one.
Yeah.
Now.
3 methyls.
Tell me what are the possibilities now?
2, 3. Wait 1 second.
Go start
2,
from basic.
2,
3. Then
2, 4.
Good. So these 2 are done now. So that means putting 2 on this carbon and this carbon are out. Good.
You can do 2, 3, 2,
good, 3, 2 line note is not done. Putting 2 on the
2,
same
3,
is
3.
done. 2,
3.
Let's not go into the 3 now. So we have covered off what now? We have covered off 2. That is 2 में दो methyl groups we have covered. All possibilities.
Yeah.
Now let's try to cover off
3 2 methyl groups.
3 2 methyl groups.
Okay. 3 3 3 3 2.
3 3 क्या आएगा? कुछ आएगा? 3 3 and 2 ही आ सकता है. Correct?
Yeah. 3 3 2 or 3 3 4 same thing.
Both are the same. So 2 3 3 is the only possibility with 2 methyl groups on the 3 3 there. Okay.
4 will be
so
the
we
same.
have covered off 4 4 also is same. So 2 methyl groups on the same carbon are done.
Now, yeah, 1 1 1 you have to see.
Done na? Accepted. Yes. This is done.
Yes. No.
So now you go for methyl groups. No methyl group. No 2 methyl groups on same carbon. Can I put 3 methyl groups on same carbon?
No. How is it? No.
Not possible. So basically, I'm going to be having only one more technical possibility left out over here.
1 2 3.
1 2 3 at 2 3.
Yeah. So 2 3 4. That's it. Yeah.
So how many possibilities now?
4.
Now we can add the shit up. Are we done really though?
Can't put 4 carbons. So yeah, we're done. Yeah.
So you're gonna make 1 2 3 4 5 6 7 11 and 17. We're not getting 18.
I'm pretty sure it's 18.
Means we missed out on something.
Yeah.
So 4, 5, 6, 7. 7 plus 4, 11. 11 plus 6, 18. We are still at 18. See, we are still at
11, 17. Yeah.
17. 17. 11 plus 6, 17.
Oh, okay.
Where did you memorize your 18 number from? How trustworthy is that number?
It was in my notes, sir.
Fact is, there are a lot more isomers here actually. But just plain structural, there is probably 7.
Oh, yeah.
So, there's going to be a lot more
18.
isomers in truth. What's the purpose of checking out what we have missed here? Why am I insisting on checking out what we have missed?
You see where the
where the process gaps.
Exactly, yeah.
So if I can find the process gap, I can refine the process a little bit more now. So
next time you can.
Yes, next time when we are checking, that is a mistake which will not be happening.
I will keep in mind.
Yes, so let's have a look at which one we have missed out on. So heptane, they have what to say, 3 we have. So heptane, they have 3. Okay, so we've got this one, we've got this one. Hexane, they are going to be having, how many did we have in hexane here? We had
1
7,
and then 7.
1 and 6, 7. So they have 1, 2, 3, 4, 5, 6, 7.
7. Yes.
Okay, all right. Pentane, they are having 1, 2, 3, 4, 5, 6, 7. Oh, they are going with the butane. Oh, yes, butane is the one we missed out on.
Oh, tetramethyl is possible, right? Yeah.
That's the one we missed out on. So 5
yes.
Our process is correct. It is just not fully complete. So we're going to be having 4 possibilities. 4 possible groups can be dumped all on these. So this is the one we missed out on. So into 1.
Yeah, that's it. So 18.
We'll start off with C4H10O2.
Okay.
I want everything possible here. Structural only.
Yeah. Okay.
Now again, I want a process where ideally we are going to be having everything smoothly identified out. So how would you start off for this year? You don't need to sit and do, you explain the process to me, we'll do it together. Anytime you are given a question of this sort, the first thing you should start doing is you should find what is called as
DU
of unsaturation.
Yeah, DU you have to find.
Okay, why is that necessary?
Because it tells you how many saturated bonds are there. Sorry, unsaturated bonds.
What does it mean?
How many double bonds are there?
Yes, how many pi bonds are present in a molecule?
Pi bonds, sorry.
Does it distinguish between pi bonds between carbon, carbon, and carbon oxygen?
No.
No, it doesn't distinguish between where the pi bond is. It only looks at the number of pi bonds or number of rings.
Yes.
So, okay. So, degree of unsaturation here. What is that number here?
It'll be 5 plus 0.
Now, before we go into degree of unsaturation, I want one very simple thing here. Let's make up a simple general formula for an organic compound. You understand what I'm saying?
Yes.
Give me. So let's say I'm having CN. H kitna hoga?
2N.
If it is completely unsaturated, completely saturated.
2N plus 2.
2N plus 2. If I have, say, X oxygens, what will happen to the hydrogens? Fully saturated.
Decrease.
So if I am having, say, something like this, if I'm going to be taking this hydrogen and I'm going to be replacing it with an oxygen, what does that basically move? I'm going to be removing this guy and I'm going to put
2 hydrogens.
I need another hydrogen anyway to satisfy it.
Yes. Yeah.
So how many are my number of hydrogens now with the oxygen?
2N plus 2.
2N plus? Total number of hydrogens, Ra. Come on. C2. 6. What is it? C2H6 is still?
Yes, 2N plus 2.
So if I end up taking this hydrogen out and I put an O and a H here, what is happening now?
C2H6.
Still
Yeah,
6.
same. Yeah, O2.
So what is this here? Will this change here?
No.
So if I have X oxygens, my 2n plus 2 doesn't change.
Correct. Yeah.
You understand the principle over here? If it is fully
Yes, sir.
saturated still.
Sir, what if it's a double? Oh, fully saturated. Okay.
That's why what was the point I first discussed with you? Degree of unsaturation, like it doesn't give a shit where the double bond is.
That's what, yeah.
You understand why I basically made sure that point was drilled in your brain first?
Yes, sir, yeah.
So this is why.
Yeah.
So that I don't have this question. I know if the double bond is present, it is going to go with the double bond rules.
Yeah.
I am not interested in double bond rules right now. I am interested in seeing how an oxygen affects my end gain of the molecular formula. No change.
Yeah.
Correct?
Yeah.
Let's put a nitrogen. Let's say nitrogen Y. What will happen to that?
Then
you use the same principle and apply now and tell me what will happen to hydrogens. So what am I going to be doing then? I will remove this
removing
and put an N.
Yes.
Fully
Means two
saturated.
more.
That means I'll have how many hydrogens on this guy?
2 more.
2 more. That means I removed 1 and I added 2.
So 2n plus 3 it will become. Or adding 1 hydrogen.
So what does that mean? For each nitrogen, I'm going to be adding
1 hydrogen.
So if it's Ny, what will this be?
Y plus Y.
So now we have a slightly more refined formula. CnH 2n plus 2 plus Y when it is OXNY. Now let's add other species. Let's say I'm having a halogen. Any halogen, chlorine, bromine, iodine, whatever the fuck, fluorine.
Yeah. Yes.
What will happen then?
Then
I'll cut this guy out and I'll put the halogen finally.
So minus 1 hydrogen. Minus Z hydrogen.
Minus Z hydrogens. Good. So for every one of the halogen species present, you're going to be subtracting 1 hydrogen. Do you understand the basic principle as to how this is going here? If I have a sulfur, what will happen then?
Then sulfur it would need 4. Then
sulfur is similar to oxygen, both same or same group. So oxygen did not affect the system.
Yeah.
So sulfur do any shit?
No.
No. So I think you're starting to get the hang of how to start looking at things now.
So what if we had phosphorus?
What is phosphorus similar to?
Nitrogen.
So what should happen then?
Okay. Then same thing happens. Okay.
You understand the principle here, na? So it's all about understanding how your periodic table has to be replicated, and that is a map. Periodic table is a map. All right. That map is something which you know. It is all about how you use the connections the map provides you in different parts of the game to your advantage.
Yeah. Sir, but then why are you only classifying into 3 parts? Why not more than that?
You think.
Oh, then they won't have any effect, right?
No, the remaining fellows are all going to be similar only. You think some more. If I'm going to be having halogen, halogen ke badle mein I can have some metal also present, like say sodium, Grignard, whatever.
Sodium, exactly. Similar to
this. If I put magnesium, that guy is going to be, magnesium will not react with this guy. It will require something else, but it will be similar to what? It will be similar to my oxygen type of situation.
Okay, valency we're just checking pretty much.
And what is the other one which is left over? Something which has valency 4, which is carbon, which is already there.
Yeah.
So, you understand the point over here, right? So all you need is 3 more extras. And see how to basically link up the shit to your original formula there.
Yes. Yeah.
Now apply your brain for this one which I've just given you.
1 second.
And now tell me why I could immediately tell you were goddamn wrong the moment you said the first 2 compounds.
Because they have a double bond. And it's a DO0.
Yes.
Yeah.
Or how much progress? What are the possibilities here?
So alcohols and ethers.
Okay, so we are going to be having alcohols and ethers. Okay, all right.
So alcohol. So
Are those the only
should
possibilities?
diol.
Hmm?
Oh, oh. Yeah, I think these are it. What could be? That's it. Peroxide.
So peroxides are not something which you have covered as of now, but they are also realistically possible in this particular case here. So let's start off with alcohols here. So we're going to be having 4 carbons. So 4 carbon long chain itself will take. How many alcohols are possible here? Different alcohols are
Five.
possible.
Five.
So how do you decide? Give me the numbers.
So only diols I'm talking about.
Yeah, I'm only looking at diols now. Only
Okay. Yeah.
diols.
Okay. Yeah. Then 1, 1.
Believe me, huh? So 1,
1,
1.
1, 2, 2. 1, 2, 1, 3, 1, 4.
Now, when you're going to be having something like this methodology here, make sure that you're doing it in a slightly different manner. First, make sure you tag off all which are going to be actually it doesn't matter. You proceed with whichever works for you. So 1, 1, 1, 2,
1,
1,
3,
3.
1, 4.
Okay.
And 2,
Then
2.
2, 2,
That's it. Oh,
2,
2, 3, 2, 3. Oh, 2, 3.
3. Okay. Then
6. That's it.
that's it. So we have, see, this is where I was basically trying to go to. You should have a better sense of the fact that in some cases, it is better not to go according to the number finishing. It is better to go as put both OH groups on 1 carbon
And
and
then
check how
single.
many possibilities, then put OH groups on single carbons and check the number of
Yeah,
possibilities.
I think that's only better. Yeah.
So, no, it doesn't, there is no better. Trust me, there is no better. You have to be flexible enough to realize that this method will be better in some cases, that method will be better in some cases. Which is better, which approach will be better, you will start realizing only when you've practiced enough. Shameful. So, my gut feeling, moment you started off with this, my gut feeling told me that's a better approach here because there's a possibility of missing something in this approach here.
Yeah.
Efficiency, which you have to look at is, will I miss? Will I, probability of me missing out on something, probability of me overcounting. These are the 2 things which you have to watch for. Those are the 2 crimes you should not perform here. Any of them is something which you should make sure is out of your process. Your process is still fine. You're missing out on a few, but you're not at least overcounting. Okay, all right. So next, what you do over here?
And then 3 carbon chain.
Done. Next.
3 carbon chain.
3 carbon chain. Okay. Now, what is left over to be put first?
Carbon.
Where can I put that guy?
Second carbon only.
Now, let's start looking at where I can put. So, 1,
1,
2,
1.
3.
3, 4.
So, 1, 1 and
1, 1 to 1, 2. 1, 3. 1, 4. And 4 meaning that. Oh, no. Sorry. Sorry. No. That'll be the same as.
The chain will change because the 2 OH groups are going to be on the long chain for damn sure.
Yes.
That cannot change.
Yeah, okay. Right. That's it then. Yeah.
Okay. All right. So 1, 1, 1, 2, and
1, 3. Yeah.
Okay. All right. Now, let's go for
ethers.
Are we done with putting 2 OH groups here, by the way? Confirmed done?
We're done with the 4 carbons, but 3 carbons. But two carbons.
Don't
Yeah,
do
we're
that.
done. We're done. We're done.
Okay.
Yeah.
All right. Now let's go for next one. What is the next best thing to go for? Is it ethers fully or is it going to be
2 ethers?
wrong?
Okay, we're just removing one OH and
One
putting an
second.
ether.
Let's continue. So,
Yeah.
why did I say one OH, one ether here? Because you've just completed the OH ones here. So,
Yeah.
your brain is a little bit more fresher on the OH groups here, and it is more.
It'd be easier to
Yes.
replace an OH with a ether.
Exactly.
Yeah.
So, let's start off here with the 3 carbon long chain now. So if I'm going to be having an OR, an ether group, I have to decide what is my ether group first. So in this case, I'm going to be picking it as OCH3 first. Okay, so
Okay.
ether, I'm going to be picking it as an OCH3 in the first place here. So if it has to be an OCH3, I need to have a 3 carbon long chain.
Yes. Yeah.
So
it will be attached to the middle one.
So let's go with the 3 carbon long chain. So 1, 2, 3.
What do I need to put now? 2 you can attach to OCH3 or no, you can attach.
What do I need to put? What do I need to put?
OCH3.
No, I need to put one OH and one OCH3.
Oh, first, yeah. Okay, yeah.
Okay, so let's start off with where all we can put the OH first.
1, 2, 3.
No. OH has higher priority or OCH3 has higher priority?
OH has more priority.
So what can I put it at?
You have to put it on the main chain. 1 or 3.
1 or 2.
1 or 2. 1 or 2. Yeah.
Not 3.
Yeah, correct. 1 or 2. 1 or 2.
Yes or no? You understand why I was unhappy with the answer there, right? That is, yes, 1 or 3 basically means that 3
same
there
thing.
Is the same as
it's
1.
Nothing but 1. Yeah.
So 1 or 2. So the OH can be on carbon 1 or carbon 2.
2 places.
So now let's start off with OH on carbon 1. Where can my OCH3 be? How many possibilities are there for that guy?
It can be on not on 1, but on 2.
Why can it not be on 1? Why should it not be on 1? Who said it should not be on?
It can be on 1. It can be on 1. Yeah.
So
it can be on 1.
So it can be on 1. It can be on 2. It can be on 3.
3. Yes.
So how many do we have?
3 possibilities.
Correct?
Yes.
Now let's put the OH on 2. Where can I have my OCH3 now?
I've done 1. 1 and 2. That's it.
Nice. Good. Yeah. Nicely done. Good. So effectively only 1 and 2 are allowed here. So how many do I have now?
2. 5.
So we have now isolated out a clean method where we can basically get this done properly.
Yeah.
You understand the process here properly now?
Yes.
So when you're breaking it down into things there, you still have to keep your brain open. You cannot switch off your brain at any second. Switching off your brain now, what does it mean? Not thinking and directly putting numbers. That is not to be done.
Yeah.
Anytime that is the assumption part there of your brain, which is telling you, oh, I know what I'm doing next. All right. Because I've seen something like this before, it tells you, oh, I know what I'm doing next. Switch that guy off. Assume you know nothing and go strictly like in this step here. What am I doing now? Why am I doing what am I doing? Question each step there. You'll get to your process.
Okay.
Now, let's go for the next one. So we have done 1 OH and 1 ether, where the ether is OCH3. What is left now?
You can take O ester as OC2H5.
Good. So we can have 1 OH and 1 OC2H5. Now let's start. OC2H5 now. How many carbons should I be having in my long chain now?
2 carbons.
Correct? Again, same procedure. Which one takes higher priority? OH or OC2H5?
Still OH.
So where can I put it in?
1.
Good. Why not 2?
Same thing as 1.
Yes. Now, where can I put the OC2H5 then?
1 second. You could put on 2.
I can put it on 1 also. I can put it on 2.
Yeah, yeah.
Fair?
Yes.
So how many possibilities now?
2.
2. Okay. So this is when I'm going to be having
alcohol plus ether.
Alcohol plus ether.
Now
If I have
ethers.
2 ethers, I will have a lot more complicated shit.
Only
Let's
one.
start with 2 ethers.
Oh, no, correct.
So if I want 2 ethers, what could my ethers be first?
O.
It can be 2OCH3.
2 O's.
Let's
2
not think too
O.
hard about what are the cases. Let's first break it down in one case, then we will see how to break it down in other cases. So you can put
1
2
OH3.
groups.
Yeah, OCH3 and OCH2H5.
We can have it as 2 OCH3 groups, correct or not?
Yes.
That's it. Now, what should be the long chain then?
Then 2 carbons.
Where can I now put my OCH3?
1, 2 or
1,
1,
1. 1, 2.
Yeah.
That's it, correct? Okay. Now, let's go for another one. If I'm going to be having 1 OCH3 and 1 OC2H5.
Then only 1 carbon as me.
Only 1 carbon is left over. And where can I put it on? Same pillow.
Only, yeah.
Correct. So I can put it as an OCH3 here and an OC2H5 here.
Yes. Yeah.
Correct?
Yes.
Now, are there any other possibilities in the first place? Can I have a 3 carbon long chain with 2 ethers?
No, you can't.
So the idea here is these are my only possibilities here.
In these, I think variations.
Sorry?
In these, again, variations will happen maybe.
You think and tell me. You draw and think. You draw and see if there are going to be variations. Draw now. Draw now.
I mean, like stereo and those stuff.
Oh, that will be there. This is just structural. All of this is just structural. That's why I was happily giving you like C4 and shit. If it is stereo also, I'll give you only C3. I will not touch beyond C3. It'll go much worse. It'll go haywire. So, itself, this next example will go a little bit haywire. Trust me. You don't see how haywire it can go. The next example will go nuts. Trust me. In this itself, it's gone quite a bit actually. Next will be even worse. Now, we are still not done. So, we have covered off alcohols, 2 alcohols, 1 alcohol, 1 ether, and 2 ethers are done. So, peroxide now, it is going to be having an OO link like this.
Okay.
So, I can put 1 carbon here and 3 carbons here. Or I can put 2 carbons here and 2 carbons here.
Yeah.
You understand what I mean?
Yes.
Okay. So in this 2 carbon case, how many are there?
Only 1.
Only 1. In this here?
2.
Why 2?
Because the C3 you can write as no.
Carbon or on second carbon.
Third carbon. Second carbon.
This entire thing becomes substituent on either first or second. So 2 possibilities.
Yeah.
Right?
Sir, why don't we study about the peroxide thing?
That is something which you will be learning about as an intermediate in learning ethers. When you have an ether, when you end up exposing an ether to oxygen, it will form a peroxide actually. And that is why when you are handling ethers in the lab, you have to be very careful. You should not directly heat them on a flame. If you heat an ether directly in a test tube on a flame, what happens is the stupid peroxide will blow the shit up. As in, it's open to the air now, it will form peroxide and it will be explosive. So when you're handling ethers, you have to be very careful, even though they are not that reactive. So you'll be learning that in ethers later. It's called hydroperoxide also sometimes. I just wanted to show you that shit can be done by your teacher even when you think everything you have done. is correct. Here there were two traps.
Yeah.
One is not two, there are multiple traps in that question there. First was your degree of unsaturation, where you screwed up in the beginning itself. Let's say student doesn't screw up over there. They might pick 2 alcohols and 2 ethers. They might not pick the 1 alcohol, 1 ether. That's another place where they can screw up. Yet another place where they can screw up is what to say?
Obviously counting.
Yeah. Obviously in the counting of the bunch there. That's enough. That's enough to screw up. How many did we get overall though? We got bunch now. 6 here. Then we had 3, 5. So we had 11.
5.
11,
13.
11 over 2. So 11.
And then 2.
13.
16, I guess.
13.
No. 16.
13 plus 2 here. 15.
17, 18, 19.
16, 17, 18. 18 ही आ रहा ना?
So there are two possibilities for that thing, right? Peroxide with 3 carbons. So 17 plus 2.
Let me just circle the fellows in red now. 6, 3,
5,
2, 2,
13, 14, 15,
2,
16, 17, 18, 19.
And in this only 1. And
19.
In this 2 and in this 1. Correct?
Yes, sir.
So 6, 11, 11,
19.
13, 15, 16, 16, 19. Yeah, 19.
Yeah.
Now, we'll go for the other nonsense. That is going to be even more complicated. C4H8O2. In this here, I do not want you to sit and explore the possible cases here, the total number of possible cases. I want you to just give me a process where to break it down into the possible cases. And if there is a new case, we'll try to analyze that differently.
Okay.
All of them will be new cases here, but still, there will be some. Let's get to the total number of cases first.
First, we should find the DU. So DU is 1.
Okay. So that means 1 pi bond.
1 double bond. Yeah, 1 pi bond should be there.
In molecule. That's the rule.
Yes.
Let's start off. What could be the case here?
C double bond O. Ester.
So let's first start off with isolating where the double bond could be. Is that what you're saying?
Yeah.
Okay. So C double bond O में क्या possibilities है? Can you tell me now?
C double bond O ester. Sorry, what's the thing called? Ketone. No, it's not possible. Ketone.
One second. Calm down. We are having C double bond O group. Okay. Now, what type of groups have C double bond O? Not just ketones.
COH, ketones.
So let's start off with calm down. We'll go step by step. So C double bond O is present. We'll start off in all the individual types. First is what?
Ketone.
Aldehydes.
Fine. Aldehyde, yes. Yeah.
Then we have ketones.
Carboxylic acid.
Or let's club the aldehydes and ketones together. Is that what you want? Carbonyl.
Oh.
Carbonyl. So we'll have aldehydes and ketones. But this is going to take care of only one oxygen. There are 2 oxygens. So what should I have along with this?
Alcohol or ether.
OH or OR.
OCH. OR, yeah.
Okay. So this is one type of case. Subcases will be there in that. What are the subcases there? We'll have 1.1 is going to be C double bond O plus OH. 1.2
so 4 possibilities.
C double bond O plus OR.
Plus OR. And there will
be in OR, there will be more type of possibilities. OCH3 ho sakta hai, OC2H5 bhi ho sakta hai.
Yeah.
You understand how complications can go over here? So let's break that down also a little bit more.
So 1.3, 1.4 will also be there, right?
What is 1.3, 1.4?
Aldehyde plus OH. And then aldehyde plus.
वही तो है ये. C double bond, I'm going to consider it as just one bunch.
Fine.
Assume it can go on whichever number. And then we'll track it as according to that. aldehyde ketone नाम पे ही तो फर्क पड़ रहा है. Priority maybe they are both very close to each other. So that's why I basically was okay with combining the two of them. Okay. Now, if we start going that way, it'll have too many unnecessary subcases. Let's not go into too many subcases. We'll keep it a little bit more easier to, what to say, manage. Next, what can be that?
This COH.
Okay. I have a question now. If I break it down in this fashion like this, does that cover my COH also or not?
That could be possible.
Shall we try that 1.1 and 1.2 a little bit now?
Yeah.
So let's go there. So 4 carbon long chain lete hain in the first case for the first guy. Okay. So where can I put my C double bond on now? I can put it on 1.
Yeah.
Or I can put it on 2. Carbon 1 la I'm going to be putting my C double bond. Okay. I can also put it on my second carbon. Correct?
Yes.
Either here or here. Fair? Because that is the highest priority group.
Yes. Yeah.
Right. Now I have to place OH. Let's start placing OH. If I put it on the first one, the OH, where can I put the OH? I can put it on the first carbon itself now.
Yes.
In which case, what is the compound called?
Carboxylic acid.
Correct. So we end up getting a carboxylic acid directly applied over here if I put it on the first one. Can I put it on the second one?
Second one, you can.
I can. And I can put it on
where? You can.
Third or fourth?
Fourth. Yes. Yeah.
Correct. How many compounds do I get here now? 4.
Yeah. So I guess with this also, esters will also be covered, right?
Yes, that's the point I was trying to make there. So you have to make sure that you are remembering. See, in this here, when you're the idea here is you need to create an approach, which is an approach. Do not be blinded by the tricks which you have learned in nomenclature. Use them when they apply. Don't blindly assume you have to follow everything you have learned there. This is more mathematics. This is set theory understanding.
Permutation. Yeah.
Yes, you have to be permutation combinations. You have to play the game of mathematics here and combine it cleverly with chemistry.
Yes.
You should not try to bring too much chemistry here. You bring too much chemistry, you will make the khichdi
too hard.
Bad in terms of taste.
Yeah.
No.
Yes.
So let's go for this here. So this was also, very efficiently, you got a bunch of things done over here, correct?
Yeah.
Now, let's go for this one here, next one over here. What is the next possibility? I can put it on the second carbon. In which case, where can I put my OH now?
Then you can put it 1, 2, 3, 4.
1, 2, 3.
No, 2 is not possible.
Why is 2 not possible?
Because valency is already satisfied.
Wonderful. Good. Excellent. That's the kind of trick which you have to start checking as well. Good.
Yeah.
So 1 is good. Then where else can I put it?
3, 4.
And check for 4 again.
Yeah.
4 is allowed?
Oh, it's repeated in the first one, no?
Is it?
Oh, no, it's not. 4 is allowed. 4 is allowed.
So, in this particular case here, why did I make you think about 4 a little bit more? Why is 4 allowed here in the first place? Because we went via priority ordering. You understand the point here? If we did not go via priority numbering, 4 would not have been allowed.
Then okay, it'll be same as 1 and 3.
Correct. So you have to be very careful about the fact that you have to follow priority ordering here. Because that is something from chemistry which is going to be helpful in organizing your information here. Okay. Now, this is just C double bond O and OH in a 4 carbon long chain. Now, make it a 3 carbon long chain. What do we have now? We will be having a C double bond O to put. We will have what else? We can have an OH and we can have an alkyl. Correct?
Yeah.
Fair enough.
Yes.
What should I put first in this case now?
C double bond O. Also, substitute, right?
What should I put first over here to make sure that my number of cases are efficiently analyzed?
C double bond O.
If I'm not accepting, there is some reason why I'm not accepting.
No, CH3, because if you put it must be in the center now. CH3
Good.
cannot be in the corner.
So effectively, the idea here is the CH3 is the one which has to take priority here.
If you put it in either corner, it become a 4 chain.
Correct. So it doesn't matter whether the C double bond O is going to be taking priority or not. The long chain actually ends up taking more priority when you're counting shit. So this is another hidden rule which you have to follow here. This is where it deviates from the priority ordering. So you have to pay attention to these kind of points here. If you blindly go with mimicking chemistry here, you'll screw up. The problem with these kind of approaches here is when you are following an approach, you get arrogance. When you know your approach is working consistently in multiple cases, you will start being arrogant. You will start having blind spots. The way to avoid blind spots, question every goddamn thing which you are doing. Because you are not going to be able to avoid arrogance. That is going to come inevitably when you are solving enough questions and getting a bunch of them right by approaches, proper process, ma'am. You will automatically start gaining what you need to gain. That's not going to be something which you can do much about that. But if your process is something which is working to weed out your blind spots, good. If your process is going to be creating more blind spots, that is not a good thing. That is something which you'll have to actively try to see how to avoid. Now, in this case here, the CH3 is something which you have to put over here for damn sure. So, my system is this now. Now I need to plop what now? I need to put a C double bond O group and an OH. Correct?
Yes. Yeah.
Where can I put now?
You can put C double bond O in one.
One only.
One. Yes,
one only. There is no other possibility.
Correct. Yeah, only one.
So OH, where can I plop the guy?
You can put it at 1, 2, 3.
Good. So this is basically the way to analyze what is going to be happening here. So in this case here, how many possibilities are here now?
3.
Now, let's go one more level more deeper into the pain.
So you can also take an alkene and
let's
yes, no?
This is C double bond O cases right now.
Oh, still doing that. Okay. Yeah.
I never said alkene is not there. There is much worse there. Trust me, there is much worse. There is rings. There's rings with C double bond, C single bond C's only, and there's going to be rings with oxygen also.
Okay, I didn't think of that. Yeah.
You're going to have like a shit ton here. That's why I didn't want to sit and count here. I just wanted you to get me the number of possibilities here. I wanted you to only start appreciating how complicated a game you're entering here is. And if your teacher wants to screw you, it's just it's an open field.
Right on the corner.
I can throw the ball anywhere and make you run like nothing else, and still not catch the ball.
Yeah.
So this was just C double bond O group's possibilities now. Okay, so C double bond O group, 4 carbon long chain done, 3 carbon long chain done. Any other possibilities here for C double bond O? Can I have a 2 carbon long chain C double bond O group, please?
No.
So these are my C double bond O possibilities. So we had how many in C double bond O itself? We had 7.
Yeah.
7. Now, next possibility. I can have C double bond C.
Alkene.
And
Plus,
what should I have along with this?
you can have two OHs, or you can have two esters. So ether.
Mhm.
Or you can have the peroxide.
No, one OH, one OR.
But peroxide
One
also works
alcohol,
like
one
that.
ether. You forgot this case last time also.
Yeah, yeah, yes.
Peroxide, skip it over here. Peroxide is too complicated here. Don't bother with the peroxide. That will just normally in the peroxide, normally don't bother.
Okay.
That is just
Yeah.
when somebody is really interested in screwing over the kids, they'll add that shit. Peroxide is normally
Yeah.
not. That's recipe to
Mm.
screw yourself needlessly, not worth it. Don't call peroxide in normal questions. So these are your standard cases now in this. So let's start off. 4 carbon long chain. Where can I put my double bond here? Why
One
am
or
I
two,
going for double bond now first?
because it gets higher priority first.
No, it decides numbering more seriously most of the time.
Yeah, that's right. Yeah.
So priority here is not really priority. Priority is number.
Yeah,
You have to be more
numbering
careful
priority.
with that idea over here.
Okay.
Let's
Yeah.
start. So in this case here, where can I put my double bond?
One or two.
Put it here or here. So let's take this as first possibility. Now what do I have to plop?
You have three possibilities now. Again.
I have to put two OH groups.
Yes.
Because for any of the other possibilities, I need to have 3 carbon long chain at least, not 4 carbon. So if I have to put two OH groups, where can I put my two OH groups now?
1, 2, 3, 4.
Now I have two OH groups.
Sorry. Two OH groups. No, my bad.
So what's the way to go about it in this case here? What did you learn about the previous time when you had OH groups? What method is better?
Putting two on one and then separately.
Good. So you remember. So go on. Explain now. What are the possibilities?
1, 1, 2, 2, 3.
Can I have 2,
No,
2?
1, no. 1, 1, 3, 3, 4, 4.
Good. You're a fast
Then
learner.
1, 2. 1, 3, 1, 4. 2, 3. 2, 4.
Done.
3,
3,4. Sorry.
3, 4. Yeah.
Nicely done, dude. That was efficient. So there's your total number of list of possibilities here. Right?
Yes. That's it.
This is Ittingrani. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is with C double bond C on the first carbon only.
Yes. Yeah.
Now, how many here?
You can put two OHs on 1 and 2. That's it. So 1, 1, 2, 2. No. 1, 1. That's it.
Good. Then
1, 2. 2, 3. 1, 3. Sorry. Yeah, 1, 3. 1,
fine.
Yeah, 1, 3. And then 2, 3. That's it.
Yep. Good. Nicely done. Okay. Next.
3 carbons.
3 carbons.
Oh, no. The OH and OR have to do it.
Can I have that in 4 carbon long chain?
OH and OR?
OR can I have in 4 carbon long chain? I need a carbon there, right?
Okay. Oh, correct. Yeah.
I can't do it in 4 carbon long chain. I have to go for 3. So 3 now.
So that R has to be a carbon chain, right? It can't be H, right?
Sorry?
The R cannot be a H, right?
Obviously not. That if it is a H, it's OH.
Yeah, that's right. Okay. Fine. Okay. I was thinking we could just directly do OH and OR, and instead of R, we can put H. So we
No,
can
that
count them.
is you can, but that will involve storing more shit in your brain for a longer period of time. You'll have to keep
Okay.
track of too much shit, nah. It's
Yeah,
more
yeah.
complicated. I'm not saying you can't. You can do it for smaller cases, not for this kind of big case.
Mm-hmm.
Now, double bond first. Where can I plot my double bond now? 3-carbon long chain. Only one place.
One. Yes.
Okay. So what groups do we play with now? We have one OH,
OH and OR and OCH3.
or OCH3. Let's start plopping them.
So
OH, where can I put it?
1, 2, 3.
Good. OCH3. Let's start with the 1 here. If this guy is on 1,
This can be
OCH3.
on 2 or 3.
Hmm?
That can be
OCH3
on 2 or 3.
also, na? It can go
How
for
can it
1,
be
2,
on
or
1?
3.
If it's on 1, then the variant. Oh, yeah, correct.
Hmm. If this is on 2,
If it's on 2, then 1 and 3. 1 and 3, yeah, 1 and 3.
hmm.
If it's on 3, then 1, 2, 3.
Hmm.
Yeah.
So how many do we have totally?
8. If it's OCH3.
So effectively, you saw the approach over here. How did we break it
Hmm.
down? First, you put the double bond. Then you look at the number of possibilities for the next guy. Go step by step by step. So you have 3 variables that are going to be playing a role here. So go first and plop the first one, which is going to be not having many cases.
Yeah. The
Then you
double
go
bond.
for the next one, which has, what to say,
Least. Second
more
least.
efficient way of ordering it.
Oh.
Then you go deeper.
Hmm.
So this is going to be the case here. So we have 8 more here. Now this is just OCH3. So I think you've already got track of how the nonsense has to go here.
Yeah, yes.
We're not going to be, I'm not going to continue on with this part over here now. We'll go for the other possible cases. What are the other possibilities from here which you can envision? You just started seeing more now, na? So you've got C double bond O, C double bond C. These are done. Correct?
You can have, yes.
C double bond C, there are other possibilities here, but we are not going to. 3-carbon long chain we have just done now. 2-carbon long chain is possible or not?
No, it's not possible.
Yes, it is.
It is correct. It is.
It is. So in this case, what can I have? I can have an OH and an OC2H5.
OC2H5.
All right. So this is going to be the case here. If I'm having, now you basically come to this 2 ethers part directly, because इसी में तुम्हें दूसरा भी आएगा. So you'll have 1 OH and 1 OC2H5, or I will have 2 OCH3. Correct? Yes or no?
Yes.
So this will cover off all of these C11C cases. All of them are done now. If we analyze these 2 more specifically, we are done. Correct?
Yeah.
Okay. All right. Now let's go for the third large case, which is going to be happening. What will be the third large case?
The ring.
Ring. What kind of a ring?
3-carbon ring.
You have multiple types of rings. You have 4-carbon ring.
5.
You have 3-carbon ring.
Oh, yes.
And you will be having.
That's it.
Now we'll go for more complicated shit. So 4-carbon ring, what are the groups first? Tell me what will be the groups.
So you have all the 4 carbons gone. Then 2
2
OHs.
Blunt. In the 3-carbon ring, what can I have? I'll have
1
multiple cases.
CH3.
I can have 2 OH plus 1 CH3. Or I
1
can
O
have
plus 1
OH
OCH3.
plus 1 OCH3.
Yes.
Now, let me show you the true pain in the ass, which will start now. We can have 2 carbons, 1 oxygen ring. We can have 3 carbons, 1 oxygen ring.
Oh.
We can have 4 carbons, 1 oxygen ring.
2 oxygen ring?
Yeah, that will happen. Don't worry.
Like oxyrane or something.
No,
Dioxyrane.
not necessarily like that. They can be like two different oxygens at different parts. For instance, let me show you a structure here like this.
Okay. You're saying like that. Yeah.
This guy is also
Yes,
an isomer
that's.
for this.
Oh, yeah, yes.
Yes, exact answer which I was looking for is oh shit, yes. So, so 2 carbons, 1 oxygen ring, 3 carbons, 1 oxygen ring, 4 carbons, 1 oxygen ring. We can also have 2 carbons, 2 oxygens ring. Technically, we can have, but I would not put the hydroperoxide type of ring. That is, I'm not interested in putting 2 oxygens and 1 carbon ring.
Next to
That will
each
be very nasty. That will probably
one
not.
carbon ring.
Yeah, that is, I'm not going to put 1 carbon, 2 oxygens. Technically, this is valid. It will be like this.
Oh yeah. No.
It's not. No. Don't think too hard. This is not going to
Okay.
be allowed. There are reasons
Is
for
that
why it is not allowed. It will not be stable in any way. We are not going to touch.
okay?
All right. So, so this is not allowed. Assume it's not allowed for whatever reasons. You have 2 carbons, 2 oxygens. We have 3 carbons, 2 oxygens. And you have 4 carbons, 2 oxygen ring. Now, in each of these, there is going to be some extra possibilities. In these 2 oxygens part here, what are the things there? If it's 2 carbons, 2 oxygens, what is missing?
2 carbons.
2 methyls or 1 ethyl. In this, 1 methyl.
Yes.
In this, nothing.
Here, nothing. That's
Nothing.
fine.
In this, what is missing? One more.
1 oxygen. OH.
Here,
OH. 1 OH. 2 OH. Sorry, and 1 CH.
1 OH, 1 CH3 or 1 OCH.
CH3. Yeah, that's what. Yeah.
Correct?
Yes.
Here, what is missing?
1 OH and 2 CH3 or 1 C2H5 or OH and OCH3 and CH3 and or OCH2H5.
Fantastic, dude. Good. You got an act for this finally, properly. Your method is also getting more and more clearer. Good. So that's the idea here. Good. So effectively, the idea here is eliminate out every possible case. And you can see this is basically each of them is going to be having a bunch minimum associated with it. And these are all only structural.
Yeah.
So I hope you have started appreciating the complexities involved over here. And that you should never, ever overestimate yourself when it comes to isomerism. Absolutely never. That is why avoid memorizing also. You cannot keep track of shit. You simply cannot keep track. Avoid memorizing. It works once in a while when you know that you are going to be given the same stupid thing vomited off in the exam. But it's better not to. It's better not to. But I will say this. It will really cut down a huge amount of time if you memorize a few simple ones.
Yeah.
Shamelessly. So, from that aspect, there's nothing there. What your teacher has given you is for that purpose.
Yeah.
Not for anything else. It is purely from the point of view of cutting down the time required for memorization. My sincere recommendation there is avoid memorizing too many. Avoid memorizing too many. They will not help you in the long run. They are basically, you're filling up your organic cupboard with junk. A better thing to fill up in isomerism is processes. What type of processes should you follow when you are sitting and doing? That is a more better thing to basically fill up the organic cupboard with over there. Okay, let's jump into the next one there. I don't want to sit on any more here. I'm assuming you understand metamerism, ring chain, and all of that stuff cleanly enough.
Yes. Yeah.
Really?
Yes. Yeah.
Okay. Tell me what kind of groups can show metamerism. I want at least
That
five
this
examples.
thing.
I want
Oh,
examples at least. Four.
ether, thioether, acid anhydride, amide, secondary amide, primary, the
Yeah,
tertiary
I
amine.
forget. Your teacher is capable. So, yeah, you got all the ones there. Okay. So, okay. So, ether. Give me the ones there. Ether.
Thioether,
Mm-hmm.
and then acid anhydride,
Mm-hmm.
secondary and tertiary amides. Sorry,
Okay.
amine. No, wait, amine.
Amine will also do. Amide will also do.
Yeah.
But you missed
And
out one which I
then
was looking for here before amide. Esters.
ketone. Oh,
Esters and ketones.
esters. Yes, esters. Yes, yes. Yes.
So
Hmm.
effectively anything where you can localize the group at a space and you can figure out how many carbons have to be plopped on either side.
Okay.
Think. What is metamerism about? You're having a centralized system and there are different number of carbons possible on either side.
Yeah.
So if you can take a centralized group and play with the number of carbons on both sides, that is metamerism straight.
Okay.
So anything which is going to be like a centralized group will work over here. Ether, ester, anhydride, amide, amine,
Amides.
amides,
Yes.
amines, all of those classes which will basic ketones, all of them which are going to be a central plopping group with carbons on either side, you can
Both
play.
sides. Yes. RR. Yeah.
So that is going to be metamerism. You're clear with metamerism then? Yes?
Yes, sir.
Been clear actually. And what else? अभी के लिए you have done chain, positional, functional, ring chain. Any doubts in the remaining parts there? Metamerism is the only one which is slightly complicated. Your system seems stable there. How about chain, positional, functional, and ring chain? Any issues in them?
No, sir. No.
Sure, fully clear?
Yeah.
Okay. So now let's plop on to the actual key thing which you have just started on, geometrical isomerism. What do you understand by geometrical isomerism? Explain in your own words, please.
Well, like the isomers are formed due to the restriction due to double bond or cyclic.
What is that restriction?
Like the bonds are the pi bonds, pretty much.
What does
They
that
keep you restricted.
effectively rotation is going to be hindered.
Exactly.
Right.
So
So if
yeah,
I'm going to be
rotational
having
isomerism.
if I'm going to be having say two bonds between two places, it's like two things connected like this. So if I'm going to be holding it like this, if I want to rotate, as you can see here, I'll have to break the graph.
Yeah.
It has to break. They end up
Yeah.
being something which cannot rotate because they end up intertwining each other. So it has to break here. So only when something breaks can I basically rotate the graph. So the rotation requires breaking of the pi cloud between the systems over there, which is going to be a problem. Same thing applies for ring also. If I had it connected like this, then this side rotation, I need to basically break one of them. I unfortunately do not have my molecular models right now here. Normally I keep it here, but I do not have it now. So next session, remind me. I have it in my car right now. So yeah, I had some work with that in the office. So I will get you the actual models and show you the idea there. I wanted to show you in Sigma Bond itself last time, but
Yeah.
that got
I
postponed at
remember.
that time. I'll get the things and show you this time. That'll be easier. Now, geometrical isomerism. What other parts have you learned so far? What kind of systems have you learned showing geometrical isomerism? Have you learned the nomenclature for that?
Cis and trans VLAN.
E and Z not yet done.
And yeah, I don't know. Yeah.
Abhi ke liye then you have not done geometrical also. Your teacher has just touched on geometrical and basically still continuing on geometrical. Is it correct?
Yes. Yeah.
Okay, then let me not poison the well unnecessarily. So let things happen the way. Any doubts so far in geometrical you have?
No, sir.
Sure.
Nothing. Yeah. Yeah.
Sure.
Yes.
Which examples have you guys talked about in geometrical so far?
Alkene, sir. Butene.
Only alkenes?
Only alkenes.
And alkenes, mein, you guys have just seen like 1 or 2 cases so far.
Yeah. 3 cases. Yes. Yeah.
Butene, then
It's croton aldehyde, and then this cinema uh, cinnamaldehyde.
anyway, or cinnamic acid, which one?
Cinnamaldehyde. I guess.
Cinnamaldehyde, okay. Basically pH and CHO, na?
pH. Yes, that's it. Yeah.
And the other one was hydrogen and CHO.
Yeah.
Okay. Okay. So you have not done anything right now in geometrical. I do not want to poison that part there. Go learn. Any other questions or doubts you have? If there is nothing else, we will wind up the session. How much time has it been today? Has it been the 1.5 hours or whatever we normally sign up for, whatever the thing is?
Yeah, I think it's 1.5 hours then. Yeah.
Chalo
That's
then. Okay. But tell me what your status is in organic so far. How are you finding it? Nomenclature kaisa chal raha?
It's fine, sir.
Fine,
mean,
matlab? Fine is a very
It's,
pity word to hear every time.
it's like it's going well. Yeah.
Okay, you're comfortable so far.
Yes.
And
So far, I'm fine.
all right. Are you practicing?
Yes, sir. Yeah.
Which book?
My teacher sent some PDFs. I'll tell you then. Yeah. It's some Pearson advanced problems in organic chemistry.
And you have
Should I
enough
send the
practice
PDF?
problems available, no?
Yeah,
Share it
but
with me. I'll have a quick look. Should be fine.
One
Your
second.
teacher has sent now that fellow seems quite good. So, and which topics has he sent in so far? Nomenclature ke liye ba?
Only nomenclature. No, I mean he sent the full book.
PDF book ka hai.
Yeah, PDF. I'll
Organic.
send it. 1 second.
Send
He
it.
sent a bunch of them, but then should I send all of
Sorry?
them? He sent like many of them. But I'm only.
You're using one of them specifically, is it?
Yes, yeah.
Has he recommended that you guys use this one, or what has he recommended?
No, he just said he didn't really say anything. He just sent in the group. So like,
I understand.
he said practice those. Yeah. If you have any.
How many books have he sent you in the group?
5.
Send me all 5 of them.
Yeah, I sent them.
Or at least tell me the
They're
names.
loading. MS Chauhan, Organic Chemistry, Advanced Problems, and then only 4 he sent actually. My bad. And then this Pearson one and this Balaji.
What is the second one you said? What is the author?
Pearson.
PS?
Pearson.
Pearson. Okay.
Yes.
Who is the author
And
name?
then 1 second. Akshay Chowdhury. I don't know.
Okay,
Never
all
heard
right.
that name. And then the last one is a question bank. GRB quota question bank.
Okay.
Yeah, I sent them, sir. I think you must have received them.
Yeah, I sent it. Okay. MS Chauhan ka 2 version.
Yeah. And then solutions are there. Second one.
Solutions. This third one is the Pearson, is it?
Yes, yeah. Third one.
And this is which one?
Balaji. I don't know the name. This also MS Chauhan, never mind.
This is also MS Chauhan only, okay.
I think a different publisher, I guess. Yeah.
And he's recommended you work on this one.
Not really, but I just did this one. It
No,
looked kind of better.
I think I know which book this is. I remember this was getting popular by the time I was getting out. So I have a feeling.
Like, it looks nice. I just wanted.
Yeah, this is very good. This is very good. Yeah, this is
The
very good.
last
No,
three
I
pages.
remember this book. This is very good.
Yeah.
This was the one which was getting popular in China campus that time as well. That's very good. You can definitely work on that. That's the best one there.
Okay.
You
Yeah.
picked a good choice. That's the best one to sit and work on. Yeah, go ahead.
Yeah. Oh, sir, I have a doubt in this. I forgot to ask. Sir,
Okay.
can you go to page number
I just closed that.
560?
Give me a second. Let me open that again.
Oh, sorry. Yeah.
Yeah, tell me.
Page number 560.
516, huh?
Yeah, you can type it. Yes. You're not.
Yeah, I realized.
Yeah. 60.
Huh.
Question number 9, sir. It's wrong, right? Like, how is that even possible?
Question number
9. CH2 whole thrice. How?
there's a tiny error, nothing big.
CH3 whole thrice.
Yeah, it's CH3 twice.
Oh. Yeah, then it would be correct. Yeah, because the H is a. That's what I thought, but then I was like, why not leave it?
So it's effectively CH3 twice.
Okay, CH3 whole twice. CHOC.
Then it'll work.
CH2OH.
This is a compound.
Okay. Fine. So
Figure out. I'm not going to waste my time on this. This is a complicated little piece of shit here. This book has a lot of these kind of
took me a
questions.
while. Yeah.
It's meant for that. So yeah, but my sincere recommendation, if you're finding this very irritating, because each question will take time, because ultimately you need some practice. I don't deny it, but you need some confidence building shit also. If you're not having no problem with taking the beatings in terms of time here, then cool, play with it. This book is the best to play with over there. But see, organic, this is why I was asking how comfortable you are in organic, because the books you use for organic have to be suited to what your comfort level is. Because the first key thing is you have to goddamn fall in love with organic.
Yeah.
If you are not feeling happy about solving organic questions, don't touch the book. Do you understand what I'm trying to explain here? Practice में भी तुम्हें प्यार आना चाहिए. It should, the ideal situation where you can say you have.
Hello?
When maths and physics you're getting bored, and to maintain
Sir,
the yeah,
your voice broke. Can you repeat?
Can you hear me more clearly now?
Yeah, now I can hear you.
So the idea here is, the ideal situation you should come to in organic is when you're studying maths and physics, you're in a flow. You're getting bored, you're getting distracted from the flow. You should use a few organic questions to basically keep the flow maintained and then come back to the other one. You should enjoy solving questions. That enjoyment factor is very critical. It should not become tedious like this. This question is tedious.
Yeah, it took very long. Like these questions took pretty long.
You understand what I'm trying to explain here a little bit more now?
Yes, sir.
I agree that this book is the best. among the ones which your teacher has sent you, which means there's a reasonably high chance 1 or 2 questions will plop up from this shitty book in your exam. That's why he sent you these. There's no other question. There's no other purpose why he's done this. This him covering his ass. No, seriously, that's all it is. Nothing much else. I've also done the same thing. So I know how the game gets played there. This is him covering his ass. There's nothing wrong with it. There's nothing correct also with it. But at the same time, that means your teacher is probably not setting the paper this time.
Yeah, he's not going to sit for a while. Yeah.
So somebody else is setting and he has gut feeling that they're going to be playing spoil sport. So my recommendation would be this. Go through this book towards the end of your prep. Go through. Like ये वाला question तुम्हें solve करने से कुछ फायदा मिलने वाला है? नहीं. What's the only फायदा you are going to be getting? You will learn how to do that kind of weird little you'll understand. Correct? That this is the key thing here. Remaining is bullshit. Fair?
Yeah.
Yes. So you learn how to name that crap. Look at the options. Figure out what's the correct answer over there. Don't waste time on these kind of questions. Recognize what is the crux which has to be learned from that question for you.
Okay.
What is the crux? How to name that type of crap. So what can you do for that? या तुम्हें ये question देख लिया तूने बड़ा गंदा question लग रहा है. Look at the answer.
Yeah, I saw the answer.
Then track it back over here and see how that thing connects. That's all. That's enough for you.
Yeah, that's what I did for this. Yeah.
That's enough for you. Don't sit and waste too much time on this book here just because there are good questions here. You understand what I'm saying? These good questions are not going to show up in any goddamn place, excepting your fucking internal exam. That too once in a while only.
Yeah.
They're not going to show up in advanced. They're not going to show up in mains for goddamn sure. Don't waste time on them too much. So organic mein, pick books which are fun for you to solve more than what will help you for exam, at least in the first few stages. So if you're finding this tedious, do it towards the end of your practice.
Before phase.
Fun shit done. You have to start feeling solving questions is fun. If you do not feel like that, please approach differently your practice, because that is necessary. That is necessary. Because in the later parts, that is going to be very critical. This is the easy part where you should find it fun. You're only going with the tedious now, not the right approach. That will give you results in this exam, but that will not work in the long run. Why am I saying it will give you results in this exam? Because you will get marks. I'm not saying you will not get marks by doing this. You will get marks by doing it.
Yeah.
But they are not going to show up in your JEE exams finally. These are false blowing your own trumpet up. So put yourself first, then you go for the marks over there. The marks are satisfying your parents in the short run only, nothing else. And they will only boost your ego up in the short run a little bit here and there. So go solve questions which are meaningful first. Check out old JEE. Same practice for everything, dude. Nothing much changes. Old JEE. And in this particular case here, I would recommend logically organic mein different stages, different books. First stage mein, if you want basic practice, comfort in that, GRB wala Himanshu Pandey is good. MS Chauhan's basic version is also quite good. That has enough complex shit in it. Up to JEE advanced level, it is good. MS Chauhan's advanced problems will be where a reasonable chunk of your questions will show up from in your exams. Along with this blue color book.
Yeah.
And MS Chauhan is going to be purely having, what to say, it's like MS Chauhan book, if I sit and solve now, I won't solve the questions. I will look at the questions and I'll know what the answer has to be. The fellow's bullshit is that all the questions will have the weirdest possible thing. It's like you go this way, you'll never get the right answer. You have to go like this and then touch. Only then practically every third question will be like that. So it's all about getting into that rhythm of scratching your ass the wrong way.
Yeah.
It doesn't help so much. Accepting it in exams. But it will help there. I will shamelessly say that it will help there. I have been in the process, I have been in enough systems to know it will help there. But it is not that it will not help in the other parts, it will help lesser. The extent it will help is going to be lesser. So my recommendation is get comfortable with questions of these calibers, but don't spend too much time, don't invest too much time on any one book. If you are investing any, large quantum of time on any one particular book, it has to be JEE related directly. It has to be old questions from JEE Mains, old questions from JEE Advanced. That's where your largest quantum has to be invested in terms of time.
Okay. So all the previous year questions, they're nothing related to like IUPAC and like isomerism. There's very less.
I am not saying you have too much in this. I never said this topic is important, did I? But previous year questions, you are misunderstanding one very key thing there. They will give you the name and they will expect you to basically do some reactions with it. So without knowing the goddamn name, converting it to the compound, you will not be able to do the question at all. You'll not be able to touch the question, enter the question.
Okay, I see. Yeah.
You understand what I'm trying to tell you now?
Yes, sir. Yeah.
When you're
I've seen questions.
You should not look at it as a nomenclature-based question only.
Yeah. You'll need to like
generally go through the organic chemistry questions. You will not understand the question, but you should look at the compound they are using there. You should know whether you know what they are.
Okay. I'll do that then. Yeah.
You understand what I'm saying?
Yes, sir. Yeah.
So that is the type of thing which you should plan for in this part here. IUPAC and nomenclature are not tested much.
Yeah.
And if they get tested, they'll get tested at a very basic level. So don't waste your time on all of this hyper complicated, hyper bullshit thing. But I will say this, you will see this shit in your exams, in your weekly exams. The fact that your teacher has given this blue book was popular in China campus at that time when I was leaving. Basically, I can see what is coming from. So Fiji used to be very good by themselves. They used to trust their own thing. Hyderabad, man, unfortunately, the competition for them is Narayana Chaitanya. So they also, the teachers there are influenced by the unfortunate teachers in Narayana Chaitanya and the China campus here. So it's inevitable. This blue book is good. Don't take it wrong. It's a very good book. It is very fun to sit and solve, but not at this stage. At this stage, it will only be tedious for you if you try to solve. At this stage, go a little bit more cleverly about it, but do not follow the clever method in that blue book for all. This chapter, it's okay. Different chapters will have different approaches, and you should try some of those questions more seriously. Because the blue book is better than MS Chauhan. MS Chauhan, as I said, every chapter is like this. The blue book is sometimes elegant. Very elegant sometimes. Later chapters, it's very elegant. More closer to JEE Advanced than MS Chauhan for sure.
Yeah.
We'll wind the session up here now. I also have to go piss. Been drinking too much water. When is your next session?
I guess Wednesday.
Okay, all right. So Wednesday then. See you then. By that time, I think another 2 or 3 sessions should be. Yes.
Yeah. What books do you recommend for like theory for organic? Or should I just stick with my class notes?
As of now, your teacher's notes are good. You're understanding clear. So nothing required on that right now. Because your understanding is quite clean. Trust me, it's not bad. It's quite clean. Your isomerism, your logics are very clean. I didn't have to really poke you much in direction there. So I don't see any problems as of now. we will see. I do not know which book your teacher is currently following. So my guess is he's probably following Claydon. What does he follow? Any idea?
Sir, he told us to get this thing called Chittaranjan Bhakta. He told it's a good book for like reference, but it's like this big. Yeah, it's very big. Yeah. Yellow book.
Yeah, yellow color, na?
Yeah, yellow.
This fat, yeah.
I don't want to get that, so I
Yeah. Send me the book's name.
okay.
And I am not particularly sure that is going to be good. I've not had a look at that book. I'll have a look at the book and then I'll comment on it.
Okay, sir. Yeah.
Because I've also, what to say, another friend of mine who I know his subject is good uses that fat book. So I know it is not bad. I don't know how good it is though. And I have not had a look at it yet. So send me the name, or if your sir has sent you the book itself, send that shit itself.
I'll try to search for the PDF. If not, I'll send the name.
Yeah, just send me the name. I don't think you'll be able to. You're familiar with Genesis Library?
Yes, sir. I'm checking there and yeah.
Oh, you're familiar with it. Okay. Then take
Yeah.
it. Okay. All right. I'll see you on Wednesday then. Bye bye.
Yeah. Thank you, sir.
Yeah, sure.
Bye.
See you.
Have a nice day. Bye.
Have a nice day.